L.
Good morning, students. So now in today's class, we have to revise the 6th unit. In the 6th unit, this is the last concept in data warehousing and data mining. So here, mainly you have to discuss the cluster analysis. We have the huge databases all over the world. From these old various databases, we have to consider as the data points. So all the data points we have to group it into a grouped as a one cluster. So now this analyze these clusters. What are the types of clusters and clustering techniques? What are the types of clusters and what are the algorithms we have to use? And different types of clustering algorithms. These all things we have to discuss in the 6th unit. See here, in the cluster analysis, mainly in this concept, you have to discuss with that what is the cluster analysis and what types of clusterings you have to use, and different types of clusters, and what is the k-mean, what is the k-means algorithm, and what are the additional issues while bisecting the k-mean, what are the strengths and weaknesses, and agglomerational clustering. So what are the types of clusterings you have to use? That is agglomerative hierarchical clustering. Agglomerative hierarchical clustering algorithm like can use the different types of algorithm. That is agglomerative hierarchical clustering algorithm. And we have to explain this algorithm. Next one is another algorithm you have to use in that clustering. Is the DB scan algorithm. So it is mainly based on that traditional density based center based approach. What are the strengths and weaknesses? These all things you have to discuss. So first one is what is the cluster analysis? So generally, the cluster analysis you can call it as the main goal of this cluster analysis is grouping to be a similar to one another and different from the objects in another. So generally, here, what are the data points you have in here, and those data points are what they are objects they consisting, and what is the relationship. These all things we have to discuss in this cluster analysis. So in the main cluster analysis, so whatever the similarity you have in that group of data points, and what is the differences are there, these all things you have to analyze by using the cluster analysis. Cluster analysis. See here, I will show the example. So here it's the algorithm. So here, what is the cluster analysis? Finding the group of objects that the objects in a group is similar and to one another and different form. The objects in another. So, for example, here intra-cluster distance are minimized. So you have to consider as these all are one group, and inter-cluster distance are maximized. I have to do that. This is regarding to the cluster management. So the number of data points you have to arrange it into a group. That group is called as cluster. Based on that cluster, next one is what are the applications of cluster analysis. So here mainly into understanding purposes you have to use that one. Clusters are you have to use to understand the concept, and second one is the summarize the data. So understanding while group related documents are browsing and group genes and the proteins that have the similar functionality and group stocks are similar to the price fluctuation. For example, we have to consider the groceries in a retail shop. So here the one group related all are group that groceries information. What are the items are there? Because all items have to be presented in a retail market. So that is related to that all items you have to be presented as retail market. So like this way, that is the understanding purposes you have to use the group related documents or items you have to present it as the name with the cluster. Here you have to cast cluster. On outside you have to call it as with the retail shop. So like you have to analyze who are the purchasing the particular item. Most frequent items. Frequent items are purchased by the customers. How to analyze? But whereas here you have to summarizing all the data. What are the items I have to purchase by the customer. So based on that data, you have to analyze. You are getting the summarization. That means overall analysis of that particular retail shop. So now you want to reduce the size of the large data sets. No need to every time you have to check it all the data points. Once you have to summarize, automatically these are the items you have to frequently purchased by the customer. That is the way you have to do it. That is the way you have to summarize. See here clustering prescription of creation of in Australia. What are the discovered clusters in industry groups, so different technologies? So that all in these applications mainly you have to use the cluster analysis. What is an R cluster analysis? Supervised classification, simple segmentation, results of query, graph partition. These are not cluster analysis. Label information, dividing the students into different registration groups alphabetically by the last name. Grouping of result of external expression, some mutual relevance and synergy, but areas are not identical. So these are the information you have to not comes under the cluster now. See here, this is the cluster with the notation of the cluster. see here in the cluster analysis, we have to discuss what are the data classification points are there. Generally, the classification points we have to represent it. What are the original points and what are the how to these original points we have to convert into clusters. See here, I will show you. This is the notation of the cluster we have to represent. These are the original points. These original points we have to divide into two different clusters. So here red square boxes are represented as the one cluster, and triangles, blue triangles are represented as another cluster. So here the cluster, the data points we have to group it into two clusters. Here you have to convert the four clusters. How we can convert the four clusters? So here first these 3 points we have to represent it as one cluster, and these points you have to represent it as another cluster, and these 3 points you have to represent it as one cluster. These are the other 6 points we have to represent it as another cluster. So totally given total data points, the original points you have to convert it into 4 clusters. Similar way, 6 clusters. So again we have to divide it. This is the clustering, the group of data points you have to convert it into different clusters. See here, what are the types of clusterings? So here you have to use the different types of clustering techniques you have to use. That is the different types of clustering you have to use. Those clusterings are the entire collection of the clusters is commonly referred to as a clustering. Generally, you have to represent it as clusterings are hierarchical clustering versus partitional clustering. So hierarchical clustering we have to represent it as root node to leaf nodes. That is the nested manner. Whereas partitional you have to divide into represent it as the unnested manner. So hierarchical versus partitional clustering, and exclusive versus overlapping versus fuzzy. So here you have to represent it the exclusive, overlapping, and fuzzy cluster. And third type of clustering is complete clustering is versus partition clustering. So here the most common discussed partitional techniques you have to use here. And now I want to represent it as clustering is simply you can say that the set of clusters. Clustering is nothing but set of clusters. So here set of clusters. So what are the data points we have to divide into cluster grouped as a clusters? Those type of clusters are called clustering. So generally these clusters are represented with the hierarchical and a partitional set of clusters. So what is the hierarchical clustering and what is the partitional clustering? Hierarchical clustering means generally a set of nested clusters organized as a hierarchical tree. From root node to leaf nodes, you have to root node you have to divide into two different branches. Like that way, you have to goes to the leaves. That is the hierarchical clustering. And the next one is the partitional clustering. In the partitional clustering, simply you can call it as a division of data objects into non-overlapping subsets, such that each data object is exactly one subset. It's called as partitional clustering. So see here, these are the original points. These original points you want to divide into partitional clustering. So how you can divide it the partitional clustering? See here, these are the clusters. This is the one represented as one cluster. This is the represented as another cluster. So now partitional clustering we have to apply. So these are the group nearest points we have to represent it as one cluster, and another points we have to represent it as another. This type of clustering is called as partitional clustering. Next one is, what is the hierarchical clustering? So here these are the different types of traditional hierarchical clustering. You have to represent it in dendrogram. So traditional and non-traditional hierarchical clustering. So here, in a cluster you have P1, you have the clusters, that is the P4 cluster. In the P4 cluster, again you have the P2 cluster and P3 cluster. So here you have to represent the data points. So in traditional hierarchical clustering, so in the P1 cluster, you have to represent P1 cluster, you have to represent it. In that P1, you have the P4. Again, in the P4, we have the one data point, and P2, P3, we have is the another cluster. So generally, this is the traditional hierarchical clustering. In the traditional hierarchical clustering, we have the 4 data points are there. P1 and P2, P3, P4, all are in one cluster. Okay. So in P1, P1 for data point, and the remaining other P1 you have represented as one branch you have to the from the root. That is the traditional hierarchical cluster. Remaining all data points comes under the other root. So here P1 you have to represent it as one subset, and P2, P3, P4 is taken as another subset. So again you have to represent it as P3, P2, P3 you have to represent it as one subset, and P4 you have to represent it as another. So like this way you have to represent the traditional dendrogram for the hierarchical cluster. Similar way, non-traditional hierarchical clustering we have to represent it as P1, P2, and P3, P4. So here P1, P2 is the one cluster data points. P3, P4 is the another cluster data points. So see here clearly it shows from the root node we have to represent the P1, P2 is one left subtree, and P3, P4 is taken as a right sub. So this is the simply you can say that hierarchical clustering. What is the partitional clustering? What is the hierarchical clustering? Next one, distinction between the sets of the clusters, like exclusive cluster, non-cluster, exclusive, non-exclusive cluster, and Fiji cluster. Fiji clustering. So in a non-exclusive clustering, exclusive versus non-exclusive clusterings, we have to say that non-exclusive clusterings points belongs to multiple clusters, can represent the multiple classes or border points. Whereas in the second one, Fiji versus non-Fiji. In Fiji clustering, a point belongs to every cluster with some weight between the 0 and 1. Weights must be summed to 1. The probabilistic clustering has similar character. Partial step complete. In some cases, you only want to cluster some of the data. Heterogeneous versus homogeneous, cluster of the very different sizes, shapes, densities. All you have to represent it with the heterogeneous and versus homogeneous clustering. So these are the regarding to these types of clustering. Next one is the clusters. Types of clusters. Clustering means the group of clusters is nothing but clustering. Group of clusters are called clustering. What is a cluster? Cluster is a group of data points. So now these clusters you have to divide into different types of clusters. First one is a well-separated cluster, center-based clusters, continuous clusters, density-based clusters, property or conceptual clusters, and described by the an objective function. See here, first one is the well-separated clusters. In well-separated clusters, we have to represent it as a cluster is a set of points that any point in a cluster is a closer to every other point in the cluster than to any point not in the cluster. Next one is the center-based cluster. A cluster is a set of objects such that an object in a cluster is closer to the center of the cluster than to be uh, center of the any other cluster. The center of a cluster is often a centroid, and the average of all the points in the cluster a medoid, the most representative point of a cluster. That is the center-based cluster. So next one is the continuous contiguity-based clusters. Contiguous clusters are nearest neighbor or transitive. Those clusters are represented. A cluster is a set of points such that a point in a cluster is closer to one or more other points in the cluster that has to be any point not in the cluster. See here in this diagram, total 8 continuous clusters are there. On all eight continuous clusters, how the data points we have to arrange. That is the continuous. These are the density-based clusters. A cluster is dense region of points. So see here, this is the density-based clusters. These clusters are mainly you have to represent as regular and intertwined. Noise and outliers are present. Mainly in the density-based we have to represent all. Next one is shared property or conceptual clusters. The overlapping of two data points at two clusters, that is overlapping sections. Shared property or conceptual clusters simply can represent the clusters that share the some common property to represent the particular concept. Clusters defined by an objective function finds the clusters that minimize the uh, minimize minimize and maximize an objective function. Enumerate all possible ways of dividing the points into clusters and evaluate the goodness of each potential set of clusters by using the given objective function. You can have the global or local objectives. Hierarchical clustering algorithms typically have local objectives. Partitional algorithms typically have global objectives, and the variation of the global objective function approach is to fit the data to a parameterized mode. So this is regarding to this cluster defined by the objective function. So next class, we have to discuss with that remaining concept. What are the characteristics and what are the agglomerator algorithm? Before discussing about the agglomerator algorithm, what type of clustering algorithms we have? K-means algorithm, hierarchical clustering algorithm, density-based algorithm. So here you have the three algorithms. K-means hierarchical based clustering algorithm and DB-scan algorithm. Out of three algorithms, you have to getting at least one algorithm. K-means DB-scan or hierarchy. This is the K-means algorithm. Figure out once. So in next class, we will discuss the K-means algorithm, the T-scan algorithm, and hierarchical clustering algorithm.